All right, everybody, welcome to Unit 5. Unit 5, we're going to start with talking about a lot of radical stuff, specifically radicals to a higher power than just 2, or than just 1/2, which would be our square root, right? We're going to talk about cube roots, fourth roots, and so on and so forth. So before we talk about those, we have to talk about some things that are perfect squares, right? So our perfect squares are like 1, 4, 9. Those would be numbers that are perfect squares. You also have to think about variables like x squared, x to the 4th, x to the 6th. Any even power variable or even power exponent is a perfect square. Thinking about perfect cubes, same manner. We have 1, 2 cubed would be 8, 3 cubed is 27. And then our variables would be like x cubed, x to the 6th, x to the 9th. Anything divisible by 3 raised to a power. Perfect fourths, okay, those are going to be 1, 2 to the 4th power is 16, 3 to the 4th power would be 27 times 3, which is going to be 81. Perfect fourths would be like x to the 4th, x to the 8th, x to the 12th. All right? So, a little bit about radicals, specifically radicals to the nth root. Notice the n right here. All right, so the n on the outside, that's called our index. That tells us what radical it is. That sign is the radical sign. We've seen that a lot. And then a value on the inside, that's called the radicand. Oops. If there is no index, so say there isn't a number right here, then it's assumed that we're talking about a square root. And that specifically, the index is just 2. All right? So, it says find the indicated nth roots of a, right? So to do this, this is saying the cube root of 64, because the n is 3, the radicand is 64. This value is going to give us 4. If we needed to plug this into our calculator, there is a way to type this out, but what I like to do is I like to just take 64th and raise it to the 1/3 power in our calculator. Okay, that's the same thing as taking the cube root. Same rule will apply with any of these things. So our index is 5, so this is the 5th root of negative 32, which would give us negative 2. Again, you could go into your calculator and say negative 32, raise it to the 1/5 power, and it would give you out negative 2. This is the 4th root of 16, so we're taking the 4th root of 16. That would also be 2. And then negative 64. This is the 6th root of negative 64. And in this case, if you took a negative to an even root, just like if you took the negative to a square root, it's going to give us some imaginary number. All right. So those are the types of things that are going on when we're looking at this. All right. So let's make a conclusion about the differences between even roots and odd roots. So odd roots can be negative. As you saw right here, right, we took the 5th root of negative 32 versus even roots. Even roots cannot be negative. As you can see, if we do an even root that's negative, it's going to give us an imaginary number. So, how about some non-perfect roots? All right, the expectation here is that you guys are going to simplify these as far as possible. So this is the square root of 117. The perfect square that goes into this is the square root of 9, which 9 times 3, not 9 times 3, 9 times 13 is 117. Square root 9 becomes 3, so then we're left with 3 square root 13 as our answer. Over here we have the cube root of 48. So now we need to think of perfect cubes. In this case, 48 and 8 would make, 48 is divisible by 8. The cube root of 8 is just 2. So that's 48, and then that's going to be 6. So the cube root of 6. Whenever you're simplifying here, you have to do outside terms get multiplied. So this 5 is outside of a radical. This 2 is outside of a radical, so you get 10. And then it becomes the cube root of 6 just drops down. All right, negative 250. So if we're taking a look at negative 250 here, all right, you could pull out the negative. You don't have to do that. But if I'm thinking of a perfect cube that goes into 250, 125 would be 5 cubed, and this is 125 times 2. So that's cube root of negative 125. Always take the negative with the cube root. That's going to get pulled out of there. And then that's the cube root of 2. So then the cube root of negative 125 becomes negative 5. And then the cube root of 2 stays, so it's negative 5 cube root of 2. And there's your answer. All right, 2 and the 4th root of 162. Feel free to practice that one to see if you understand what's going on with these. All right. Next up, we have a rational exponent is a root. Okay, I've actually already talked about this earlier today. So rational exponent just means that it can be written as a fraction. Okay, so like 4 to the 1/2 power, that would be a rational exponent because it's written as a fraction. This is the same thing as the square root of 4. So what's the big idea behind this? Well, if we have an nth root of something, it can be rewritten as a to the 1 over n. Where does the 1 come from? The 1 specifically comes from the exponent that a has. So 1 over n. This n is the same n as the denominator here. So then if a has an exponent on it, then it's going to be a to the m over n, just like that. So the next question says convert to radical form. So this is 81 to the 3/4 power. That's telling me that 81 is going to be raised to the 3rd power because the numerator always goes on the radicand. And then it's the 4th root of that 81 to the 3rd power. Okay. Convert the next one to exponential form. So this is saying 3 to the 4/5 power. The index always goes on the bottom, the power always goes in the top. Okay, so what do we have up next? Next it says to evaluate the expression. So how exactly are we going to do these ones, right? So it's saying it wants 16 to the 5th power square rooted. Well, you could write it like this, or you could write it like this. The square root of 16 to the 5th power. These two things are actually the same. And sometimes doing it one way is easier than doing it the other way. Here, raising 16 to the 5th power is a huge number, versus if we just take the square root of 16, you get 4, and then you can take 4 and raise it to the 5th power, and eventually end up with 1,024. All right. Next up, we have 9 cubed square rooted. Again, this is probably one that's easier to do the square root of 9 first, and then cube it. So that gives us 3 cubed, which then gives us 27. Ooh, okay, negative exponents here. They're coming back to haunt us a little bit. All right, so it's important that we know those negative exponents that are what exactly they do. Remember, negative automatically just drops or flips the term into either the numerator or the denominator. So this one's starting in the numerator, so negative flips it to the denominator, so 1 over 64 to the 2/3. All right. Now we have 1 over, I like to always change it to radical form, so we have the cube root of 64 squared. All right, and then from this, we have options. We could take the cube root of 64 and then square that number, or we could square 64 and then do the cube root, right? So we've been doing the cube root and then squaring, which in this case probably would be easier because we would just take 4 and we would then square it, right? The cube root of 64 is 4. But just to show you an example, right, you could do 64 squared. So 1 over the cube root of, this is going to be 4,096. And then we literally just have to do a ton of simplifying from here. So you're thinking biggest possible perfect square that goes, or perfect cube that goes in there. Actually, you don't even need to do that. You can just take smaller perfect cubes the whole way along. So like cube root of 8, right? You take 4,096, divide it by 8, you get the cube root of 512. So the cube root of 8 is just 2. Well, cube root of 512 is the cube root of 8 again, and then the cube root of 64, so that gives us 2. Cube root of 64 is just 4, so that's 2 times 4. So then this final answer is 1 over 16 when you multiply 2 times 4. All right, and last but not least, number 14, so that's 1 over 32 to the 2/5. Okay, so let's go back to take the 5th root first and then square it. Just much easier that way, right? So that's 1 over 2 squared, which gives us 1 over 4. All right. So, those are some examples of simplifying when a power is raised, when a value is raised to a fraction. So let's talk about square roots, right? Exponents must be in multiples of 2. We've already talked about this. This would be x. This would be x squared, x to the 3rd, square root of x to the 11th. Now this is where it gets a little bit trickier, okay? What you need to do is you need to split this into the square root of x to the 10th. That's the next smallest perfect square, and that would be multiplied by the square root of x. X to the 10th times x would be x to the 11th. Square root of x to the 10th is x to the 5th power. So that's x to the 5th power times the square root of x. All right. If you're not sure how that's working, think about it in its fractional form, right? This is the cube root of x cubed. That's telling us it's x to the 3 over 3, which is just x. This next one would be x to the 6 over 3, which is just x squared. This is x to the 9 over 3, which is just x cubed. X to the 16 over 3, so again, split it. That's the square root of x 15, cube root, x 15, cube root of x. So this is x to the 5th again, so x to the 5th cube root of x. Alrighty, last one here. So x to the 4th root of x to the 4th is going to be x. This is going to be x squared, x cubed, x to the 21/4. You could think about it like this if you're struggling with the other method. X to the 21/4 in fractional form. That would be x to the 24ths multiplied by x to the 1/4. Exponent rule says you would add these two together. That would give you your 21/4. 20 over 4 is just x to the 5th multiplied by the 4th root of x. Or you could even keep it as x to the 1/4 if you prefer. So you have options when you're simplifying these. You can put it in its fractional form. You can leave it as its radical form. Both are great methods. So let's do some of these harder simplifying questions. So now we have the square root of 32, x to the 4th, y to the 9th. So square root of 32, biggest perfect square that goes into that. We have the square root of 16, square root of 2. X to the 4th, when you square root it, just becomes x squared. y to the 9th power, you need to split it into its closest even power. So that's the square root of y to the 8th, square root of y. So that's going to be the square root of y to the 8th becomes y to the 4th power. So then everything in a radical stays in a radical. Everything outside of a radical gets multiplied together. This is 4. So we have 4x squared, y to the 4th, times the square root of 2y. And that is as simple as we can get it. Okay, so let's take a look at another one. 324. Okay, 324 is a perfect square, actually. It's the perfect square of 18. So we have 18 there. A cubed, so we need to get it into its next smallest exponent that's divisible by 2. So that's square root of a squared, square root of a. B to the 7th is the same thing. Square root of b to the 6th times the square root of b would give us square root of b to the 7th. A squared becomes a. Square root of b to the 6th becomes b to the 3rd. Everything outside of a square root, everything inside of a square root. So we have 18a b cubed square root of a b. And there's your solution. All right, let's take a look at some cube roots. So 216 is a perfect cube. It's the perfect cube of 6. M to the 3rd power, also a perfect cube. That would just be m. N to the 6th power is also a perfect cube. That would just be n squared. So this is just 6m n squared, and we're done. Okay, so some are nice and quick. Others definitely take a little bit longer. Number 4, we have the cube root of 56. All right, so 56 is 8 and 7. So that's going to be the cube root of 8, cube root of 7. Coming there. R to the 8th power is going to be the cube root of r to the 6th, cube root of r squared. And then s to the 4th is the cube root of s to the 3rd, cube root of s. Okay, and if you're still struggling with this, s times s cubed gives you s to the 4th. R to the 6th times r squared gives you r to the 8th. All right, that's how I'm getting those numbers. So then we have this becomes 2, r to the 6th becomes r squared. Whoops, I deleted the s's. Cube root s3, cube root s. And then so that becomes just s. And then inside we have 3 terms. So we get 2r squared s, cube root of 7r squared s. And there's our solution. All right, number 5. Number 5, we have the cube root of negative 64. That is the perfect cube of 4. X to the 10th is x to the 9 and x. Y to the 21 is divisible by 3, so that's y to the 7. Cube root, so this becomes x cubed. So we have 4 x cubed y to the 7, and then that's the cube root of x. Cube root of negative 81, so that's going to be 27 and 3. So the cube root of negative 27, cube root of 3. P squared is going to stay. There's nothing we can simplify p squared down into. Q to the 12th power is going to become q to the 4th power, because 12 divided by 3 is 4. So this is inside, this is inside. This becomes negative 3, so outside and outside. So that's negative 3, q to the 4th. And then cube root of 3p squared. And then there's our solution. All right, number 7, we have a 4th root. W to the 4th is just going to become w. This is 4th root of v to the 16, 4th root of v. V to the 16 becomes v to the 4th. So w v to the 4th, 4th root of v, and we're good. And then last one here. Sorry, I know these notes are kind of going kind of long, guys. Just a lot to show you today. 4th root of 48. So 4th root 16. Yeah, 4th root of 16, and that's multiplied by the 4th root of 3. M to the 8 is going to become m squared. N cubed has to stay. This is inside a radical, and 4th root of 16 is just 2. So we have 2m squared, 4th root of 3n cubed. All right. So that was a lot of good examples. Again, if you have any questions, message me on Canvas. I'd be happy to try to just explain it in a different light, or maybe just give you a video example of something that you need to see. As always, guys, have a great day.